Hello and welcome, everybody. My name is James, and I'm very excited to be here today with Nicholas and Jason as we wrap up CubeWise Innovation Week. We're at day 5, and it's been a great week with a lot of presentations. I'm going to do a quick recap on what a fantastic week it's been. And before we kind of launch into today's topic, which is definitely one of my favorite topics, which is how fast is fast enough when loading data into TM1 and around TM1 as well. And we're going to be talking about that from a kind of like a pipeline perspective and kind of diving deep into that very shortly. But I just want to say firstly, thank you to everyone from the CubeWise team and everyone who's attended these presentations, of course, as well. This has been this is our first CubeWise Innovation Week that we've done, and it has been a fantastic success. And so a big thank you to everyone who's participated and attended in this event. I really hope you found it very informative. We've gone for a little bit of a different style, where we're trying to kind of go for a bit more of a relaxed conversational style. And I hope that's kind of been a little bit more, a bit different and a bit more enjoyable for you all. And I guess, why are we doing all of these things? As I kind of mentioned in a couple of the webinars and some of the other hosts, Jason and Andrea, is that we're doing this because it's in our DNA to kind of CubeWise to share our knowledge and to help, advance the planning analytics community. I think it's fair to say that the planning analytics is probably at its best, most vibrant and most dynamic and best stage, at least in my experience with the technology. And this continued the innovation and the advancement and the opportunities here is as Ryan Clapp said on Tuesday, the potential with planning analytics and the use cases are effectively endless as we kind of march towards version 12. And what we can do with the REST API and MDX, and there's just it's just a very exciting time. I'll say that. So that being said, let's kind of just have a quick recap about what we did this week before we really kind of jump into what we're going to be talking about today. So on Monday, I was hosting, and I was there with a number of the CubeWisers as we launched Power Connect. And we kind of had a bit of a deep dive and a bit of a walkthrough about Power Connect, which is our integration utility between planning analytics and Power BI. And we kind of had a look at that and how it differentiates itself in the market when we're talking about data and metadata and security integration between planning analytics and Power BI. And David, our technical account manager based out in San Diego, walked us through some of that. And Guido, one of our senior engineers based out of Massachusetts, was kind of talking about the importance of security and the architecture and prerequisites. And then Vincent from the CubeWise Code team, made the great announcement that it is now Power Connect is now globally available, and we're seeing a lot of buzz, especially in Europe and Australia, as they are now able to kind of start their proof of concepts, their 30-day trials with Power Connect. So again, if there's people on the line who are interested in that integration utility, please reach out to CubeWise. We've got a new website launching this weekend, which is pretty cool. And so please reach out to either your local office or kind of just submit the contact us on the new website. So that was Monday. And then on Tuesday, Jason, you were hosting on Tuesday. Tell me what happened on Tuesday and why was that that was a really big success, that Tuesday session.
Yeah, I'd say so. I'm a little bit biased because I was the host for that one. But so day 2, we had a conversation with Marius, the father of TM1 Pi, Shane, one of my colleagues, and Ryan Clapp, who's from Amazon, on their experiences on implementing solutions in version 12. We also talked about how TM1 Pi 2.0 is out now, and that supports Planning Analytics version 12. And I think the best part about how it supports version 12 is that you don't even have to worry about what version of Planning Analytics you're using. So if you have, I don't know, if you're transitioning from one to the other and using TM1 Pi to do things in between, you don't have to worry about what the versions are. You just use TM1 Pi. But just generally understanding the next generation of Planning Analytics in more depth, for me, it was useful. And I hope it was useful to the rest of the audience as well.
Yeah, no, guys, right call there, Jason. And yeah, that was a really well attended session. Some really great feedback there, and a big shout out to, of course, all of the team on that call, and also a big shout out to the TM1 Pi community and the TM1 Pi the working group that is associated with it, that is kind of putting together and innovating. It's a community approach, right? It's an open source program, which is of course sponsored by CubeWise. We're heavily involved, but it is really we're seeing globally, the uptick and the of T1 Pi is really exciting, and it's a great way for us to innovate and integrate with different applications. And then I guess moving a bit forward, on Wednesday we launched Atmosphere, which is our serverless cloud functions. And I was on that call there, and that was really exciting to be sharing with the community about how we're moving forward with that Atmosphere, which is a new innovation lab solution which is being incubated in North America, and how that's going to accelerate our deployments, our integrations with things like Salesforce or Oracle or SAP. The data connections are effectively endless. But I guess Nicholas, you've been part of the Atmosphere working group at CubeWise. What are you really excited about Atmosphere?
Well, I think it's mostly that it fits, right? It fits perfectly with the new world of the cloud, because it's not the cloud, it's clouds, right? No company is just putting all their eggs in one basket, and it's really important that we have an easy way, as much as out of the box that we can connect all of these clouds together. And I think Atmosphere does that really elegantly and securely, and it's actually something that we're going to talk about in this meeting.
Yeah. And one more comment to add to that is what Atmosphere does. A lot of what Atmosphere does can be implemented with TM1 Pi. I think that one of the cool things about Atmosphere is it sort of lowers that barrier, so that it kind of removes a technical barrier if people aren't so familiar with TM1 Pi. Because with Atmosphere, you don't have to install anything, you don't have to host anything anywhere. It just works. And I think that is in and of itself a huge value proposition in that solution too.
You're right on there, and the ability for us to now, instead of writing custom code to integrate with different data sources, the ability to kind of call a function from a library to enable us to kind of quickly integrate with a Salesforce or an Oracle or SAP or Databricks or Snowflake, or Google Cloud or SharePoint, etc. And there's another really great innovation that's part of Atmosphere that got developed from our CubeWise Asia teams, and that's a report distribution utility. So we're able to kind of burst T1 web reports as an example using Atmosphere to users, which is, I think, really exciting piece of kit there. Excellent. So that was Atmosphere, and then moving along, like Nicholas, back to you. You were, you're one of our subject matter experts here on DevOps, and that was a really well attended session. We was talking about DevOps and I guess the culture that is associated with that, and the policies and the thinking that goes with DevOps. And then we also have Ian Bolts from our UK office, who was talking to us and updating the market, so to speak, in relation to Test Center. Do you want to just share a little bit about why DevOps why you're passionate about it, and where do you see DevOps going within planning analytics over the next 18 months?
I think it's slowly coming. I think in a way DevOps is becoming more and more an industry standard, and the reason why I wanted to start with it was so that TM1 stops being seen as the awkward child in the room, and you can see that it can actually play along with any other application, enterprise level application. We just need to figure out how. IBM has acknowledged that years ago when they started building the APIs, so that TM1 can actually be out of the box, right? And it can be available for integrating with other applications. And this is just one of them. And it's, I think, one of the most important ones, because DevOps is coming for you. So you better be ready.
Yeah, and
please, Jason.
And because planning analytics and TM1 are used, it's a very flexible platform, right? So you can have use cases all over the place in your company. And when you have such a big use case in your company, you better be making sure that you're managing the development of it and lifecycle management of it properly, because it could end up being such a critical solution for your company. Ryan Clapp the other day talked about how it's used more as a service at Amazon. So if you take that into account, it's used by a lot of different applications over there at Amazon. So you need to be very mindful about how you're approaching development.
And especially as we see, planning analytics, if you kind of think of it as a departmental solution versus an enterprise solution, when we're really kind of getting into planning analytics as an enterprise strategic tool, as you said, that has many touch points throughout the I guess the information management systems of a large organization. Additional care, additional guidelines, additional policies, are really beneficial to planning analytics, to ensure that it's highly available, to ensure that it's the production is always up. Heaven forbid you're going into production and making a live change to a rule or a TI. They can have some really unanticipated consequences. And again, if we're kind of wanting to be working with our IT colleagues, and again, at any level, having these additional kind of thinking and additional policies and procedures is good for planning analytics, and it's really is recommended. And we're seeing increasing amount of, I guess, organizations where IT is coming to the planning analytics team and saying, we would like to encourage you to start kind of doing more in this space, and here's frameworks and policies that we use with other IT programs that we would like you to kind of sign up for. So this is I guess something to kind of be mindful of, especially if we're kind of looking out 18 months here. I think this is going to be a topic which we welcome. Again, if we want to have really stable and highly performant applications, this is a great thing. It's something great to explore. Okay, and that was DevOps. Okay, so that was a great topic there that Nicholas and team were on, and a big shout out to the team that was participating in the DevOps session. So I guess now let's kind of get into what we're doing, what we're talking about here today. And as I said, you were talking about faster data processing within planning analytics. And I guess the overarching question here, which I'm going to ask Jason, and is, with your experience, working with CubeWise, as a technical account manager role, you've worked and supported some of the largest planning analytics installs from a server perspective, at least in North America. And, from your perspective, how fast is fast enough? When you speak to your customers, and you speak to, either it's a VP of finance, or it's the VP of FP&A, or it's a TM1 administrator, how fast is fast enough when we're loading data into planning analytics? And maybe Nicholas, if you want to share your screen, let's kind of jump into some of the slides that we have.
So James, that's a loaded question, and I think it's probably worth exploring the question, why is being fast important? It's kind of self-explanatory in a way, but if you think about from a user experience perspective, applications that directly impact the user experience, like someone's actually going and touching it, when it comes to processing data, users expect near instant responses. Like, for example, if I'm on my phone and I'm Googling something, the second it takes a little bit too long, I kind of feel myself getting irritated. And I know that, managers of planning analytics applications want to make sure that the application is as inviting as possible for users, right? So it's important to make sure that they don't get frustrated with things that take too long, right? The second thing, the reason why performance is important is for the real-time analytics aspect. So data is changing quickly, right? And if and businesses need to understand or leverage the latest data. So making sure that, let's say, like an allocation runs as fast as possible, or some kind of other complex analysis runs as fast as possible, is important for proper decision making. So to answer your question directly, it sort of depends. I'm not even sure if fast is ever fast enough. But you can think, for example, an allocation process with intersections from, thousands of SKUs, now let's say millions of SKUs, thousands of customers, and hundreds of vendors. Okay, let's say the allocation process takes 2 hours. The answer is, if that's fast enough, is probably no, it's not fast enough. It could be, though, it could be because reasonably that's a high volume of data, but it's not fast enough if, for example, you need to run the allocation in 1 hour intervals for some reason, something like that. So in that case, what we thought was fast is not fast enough. So in summary, it depends, but you should generally be looking for ways to get faster all of the time. Nico, what do you think?
Similar. I think that especially in our case, in TM1, where TM1 is also part of a chain, right? Data is hardly static today. It goes from different places and gets enriched and analyzed in different tools. It's important that you can get it quick, analyze it, and get it out. In the overall pipeline of data within a company, TM1 being an important in some cases, not that important in others, in the chain, it's important that you can make it fast. So if the data needs to start and end in a given period, going through the entire pipeline, you can accomplish that. Because if the data is needed to be processed and analyzed by TM1 to then be outputted into another tool that it's also used, it's important that you do it that fast. And yes, I mean, if there's always ways to improve it, and I think if we can say that it's as fast as it can be, it's fast enough. But it's generally hard. There's always room for improvement.
So I have a quick follow-up
Jason,
question.
go for it.
Quick follow-up question. So Nico, in your experience, so you talk about the pipeline. In your experience, are there areas or parts of the pipeline that come up more often as areas that you need to address when it comes to performance? Or is it?
Yes, I mean, yes, I think in terms of pipeline, I mean, it will really depend on the implementation, I think. But I think we put together some of the things we generally take a look at, because again, it's not just how fast you can commit to a cube, is how much the overall process takes. So there's generally TM1 does not fabricate it; it generally ingests it from a source system, and then it gets imported and analyzed and maybe it can run some calculations, and those calculations can go elsewhere. So this 5 steps that we have here are basically common, especially some of them in cloud only when we talk about uploads. But these are the most common stages of the data pipeline analysis, and things that we can do to them.
And it's part of that analysis. I know, like, when we kind of typically when we engage with a new customer, as an example, at Cubewise, when we get an inquiry where a customer already has an existing planning analyst install, and they might be inquiring about a health check. I know Jason, from we call them a system analysis and optimization engagement, and increasingly we looking to kind of like infuse AI with our health checks to kind of provide extra value, and also increase the speed of our health checks as well. But you're doing a number of them right now as well, health checks with customers. We're talking about AI infused health checks. Like, how do we typically start an engagement where we're looking at this data pipeline for customers, and what parts here, based on your experience, do you think are really important?
So obviously the inside of TM1 piece is extremely important, and what helps us accelerate our health checks is, among other things, Pulse. So people on the call, Pulse is, among other things, helps us accelerate health checks, because we can analyze a lot right there. Everything from cube statistics to, over time, the duration of TI processes. And we can also evaluate the efficiency of code within TI processes and rules and things like that. So when we approach health checks, yes, we can, there's obviously value that we bring to the table with our experience, but we have tools that sort of help automate the discovery of some of the challenges that the customers are talking to us about. And actually drilling down a little bit on the things like chore process history and Pulse, for me, that's very valuable, even outside of health checks, because being proactive about performance is important to our customers. And so having the ability to look at chore and process history over a long period of time enables you to be proactive about performance challenges before users start feeling it. And I think that is one thing that I'm a little bit bigger on is being proactive about these things rather than being reactive to them.
Yeah, and I guess like similarly, like so, like Nicholas, you're doing a number of these similar engagements and analysis with some of our big enterprise customers right now, where we're reviewing the pipeline. Maybe you're just kind of going a bit further, the importance of this pipeline and maybe as we kind of get into the next slide here as well, what are some of the tools and for parallel loading and how do we kind of accomplish these outcomes? Because I know from my perspective, when I was first introduced to planning analytics, or TM1, when it was like 9.5.2 back in the day, I was an end user and administrator of TM1. And that's where I kind of had that moment where we were sitting there kind of during month-end close, and the calculations, and we were kind of in the allocation models. I was working at a utility company, and to get a refresh number out of TM1, it did take after the calculations were done, it would take end to end maybe an hour and a half. So we were there sitting in finance waiting for the calculations to finish. Our computer was kind of hanging back then, and we couldn't kind of do much with Excel. And that's where I kind of had my light bulb moment of like, we need to be faster. From an end user perspective, we need to have almost instantaneous numbers to be created so we can get onto the more high value things such as analysis of the underlying data. So I've always had this pursuit of it can never be fast enough. So because we want to enable our users to have very responsive, accurate and numbers, so they can kind of drive forward and do their analysis and do what is valuable to them. So, but Nicholas, what's your thoughts on this? When you look at this pipeline, what do you think it's an extra consideration?
Well, I mean, you're right on. You're basically that scenario. You're the end user and you want things fast. And I think that the multiple things that we can analyze, what I faced during many years in different companies, especially migrating from on-prem to cloud, which is something I did many times. These are the key components. So, for example, I've seen multiple examples of data systems exporting a year worth of data, or an year to date, or even monthly. And in some cases, you just need to go back and ask, is it really needed? Can we just use deltas? Why are we ingesting 3 gigs every day of data? Is it really that much data being generated? Can we shrink that down? And in most cases, you can. Producing those files is also something important. Don't produce them all at once. Produce them sequentially. Do them in parallel. If you have small files eventually, and you're on the cloud, you can use TM1 It's great. It has been improved a lot in terms of performance. Of course, if you're talking about 500 megabytes or 1 gig of data, you need a big server to get that data frame and to push it. But the data transfer is extremely secure and it's fast, right? It's fast as a TI process. So that's another important component. Your cube structure. How are you, like the pipeline inside TM1? Are you, generally speaking, I've seen many cases where the processes update a cube that is user facing and it has tons of calculated rules. That's generally a problem because you're going to get a lot of contention. Performance is going to be lower. So maybe try to break it down, create a staging cube, then move it to an input cube. That's much more efficient and less error prone. And the same thing, this is more of the separation of duties, right? Like calculate, if you have heavy calculations like variances, do them in a separate cube. Don't try to blow up one cube with everything, because it's going to respond by being slower. And the same thing with the exports, right? Like try to have report cubes or export cubes that you can parallelize the exports, and that would make things much more efficient. Again, these are globally speaking the things I've seen so far. But the idea of parallelization has to be as much embedded in all of these things combined.
And getting back to like the overall pipeline of things, an example recently was a customer that I was working with. Not suddenly, but in a relatively short period of time, there was a sudden decrease in performance of an actual load process. And we were asked to basically look into ways to parallelizing the data load into TM1. But we ended up finding, with some guidance, we ended up basically taking a look at the entire pipeline. So what is the percentage contribution of the performance drop? Where does that come from in each part of the pipeline? And we were able to actually determine that most of the time was spent on the database side. So there was an Oracle upgrade that happened recently. So what we decided, so what our recommendation was to see if we can address that first, because that was the sudden change. And then we can, on top of that, see where we can squeeze the most performance out of TM1. And that's sort of when we get into, you know, different multi-threading approaches and how to manage threads. And we can have a whole discussion on that, which I'm sure is coming up.
And maybe just before we get onto that next slide, I think, you know, similarly, so I think with the big kind of like recommendation here when people are talking about like how fast is fast enough, is we kind of recommend you kind of take a step back and then look and kind of like segment the data pipeline and analyze it. And we'll show some, Nicholas will shortly show some tools about how we can analyze the performance of data processing with planning analytics. We'll have a look at that shortly. But really kind of step back and have a look at, you know, the different components in the pipeline and analyze and give it some critical thinking about how we can, you know, improve the performance of each stage of the pipeline. You know, I think, you know, it's fair, you know, you talk about that, Jason, before, and Nicholas, about, you know, separating, like, you know, it's advantageous to kind of at times to separate, you know, your big calculation engine from your reporting engine in planning analytics. You know, yes, you can have everything in one cube, you know, because planning analytics is enormously flexible and scalable. But is that the best approach for the end user and for kind of a recommended architecture approach? I would say, you know, as you want to scale more and you want to kind of have an enriched user experience, you know, challenge yourself to say, well, should we have maybe a separate instance or separate cubes that do a lot of our number crunching? And then we have, you know, a separate instance or a separate set of cubes that is for the pure reporting, that are like, you know, tailor-made for reporting. So they're, you know, very, you know, highly performant, very easy to use. And, you know, they're easier to integrate with maybe some BI tools as well, if that's kind of interest. But again, you look at this and kind of challenge ourselves to parallelize things, to chunk things up, and to analyze this based on the different stages of this pipeline that we're discussing here. So
James,
maybe on the next, please. Yeah.
One thing before we go on, you had just mentioned an option, like an architectural option would be to have separate TM1 instances. We've actually had conversations with our clients before on this, and the concern had been, well, if we have separate instances, then how are we able to like share the data? And the answer is, like, in 2024, you don't have to necessarily worry about that anymore. With the REST API and what we actually do with our Python data sync or data syncing mechanism is we can very, very quickly share related objects or make sure that object, like dimensions are in sync between two instances, or data is in sync within two instances. So that technical limitation isn't really there anymore. So it's really about thinking about what are all the possibilities that you can possibly do in TM1, and there are a lot. And then choosing the appropriate one for your sort of use case. But old limitations that used to exist are kind of no longer there with some of the technology that's out there right now. Just wanted to add that.
That's a fair point. Yeah, no, it's a fair point. And let's jump into the next slide and talk about a few more of these things here. And again, for people on the meeting, and there's some great attendance here, so I hope you're all doing well. Please feel free to ask some questions in the chat. This session is recorded and will be shared afterwards as well. But yeah, please drop some questions in the chat there. We'll be putting some links in there very shortly. But again, I really welcome any feedback or questions you might have in relation to this topic or anything else, to be fair, in the planning analytics universe. I guess the other thing about that data sync, you know, utility that we're talking about there, you know, again, you know, in 2024, the considerations, whether you're on-prem or on cloud, or it's a hybrid deployment, whether you have servers in Australia, the UK, the US, you know, that's all doable. You know, syncing data between different instances and servers, no matter where the physical location is, whether you're on cloud or on-prem, or it's a, you know, mix, you're on AWS here and Google somewhere else and Microsoft or an IBM cloud in a different location. All of that kind of data syncing and those kind of concepts with T1 Pi as an example, are very achievable, and it's something at CubeWise we do actually quite regularly, because we're very fortunate enough to be an international organization where we work with a lot of international companies that have environments spread out globally, and their users are spread out globally. So we have to kind of consider when it's the time zone difference, and when we're doing calculations and where the users are. It's a really kind of a neat consideration that we have to kind of work through a lot at CubeWise. But yeah, putting that to one side, what about this, Jason? This is a great slide, and Nicholas, about parallel loading tools. Let's jump into this.
Yeah, so there's a long history of tools that can be used to help parallelize data. So one of the earlier ones, I think, was T1 Run TI, which was or is an executable that allows you to pass parameters via the command line. And so in a TI process, for example, you can run the TM1 Run TI executable with the execute command function. The only downside is that you cannot necessarily easily manage threads with T1 Run TI by itself. And that kind of brings us to Hustle, which is a CubeWise solution. And it's a utility that allows, or that supports, it kind of uses T1 Run TI, but it helps you manage the threads a little bit better. But there's even more, there's later technology. So Rush TI, which I do have experience with, essentially is a Python script that allows you to execute multiple processes in parallel, but using one connection. So you're logging in into TM1 one time. So it works similar to T1 Run TI, but you can manage this just using one connection connected to TM1. Then comes my favorite, which is Run Process. That's a TI function that allows you to, I think it was released somewhere in version 11, that allows TI process executions on their own threads. So you can, if you call a child process many times from a master process, each child process will have its own thread ID. The challenge with Run Process, at least in version 11, planning as version 11, is managing the execution of threads. And we have a way that does that, a really nice way that to do that. And in fact, the solution that we use to help manage threads in real world situations, we also use to do analysis on what the best combination of dimensions to parallelize on is. So, for example, we might have a theory or a hypothesis that multi-threading on the months dimension or something like that is going to be efficient. So we'll test that. Then we'll test, okay, let's multi-thread on the combination of 2 dimensions. And using this 3-dimensional thread tracker cube, we can actually see the performance of every single thread and how much the total runtime is for all of the threads. So it's kind of a way where we, initially we come in with a hypothesis, and then we kind of do trial and error until we figure out, actually, with quantitative analysis, what is the best combination of dimensions to multi-thread on today. But obviously, remember, we have data changes, businesses change. You can acquire another company, and as soon as that happens, you have more data, and then you might have to reevaluate your approach slightly. But these are some of the approaches that we use. Run Process happens to be one of my favorite, but I know there's recent updates to Rush TI. Nico, you're probably most familiar with that, but I know that there have been improvements to that function.
So yeah, one thing that I would outline. So the first two, though really popular, are with V12. You're not going to have them anymore. So that's important for you to start thinking, because the authentication method is going to be gone. So Rush TI and Run Process will remain. V12 has a specific new set of functions to actually track run processes. So you can call them all at once, but keep tabs on them. So that's a really cool new feature. And Rush TI, I love it because it has not only has a really great performance, because it has TM1 Pi under the hood. Every single improvement that you have to TM1 Pi, you get in Rush TI. And it also has its own set of features, like submitting an MDX as a parameter, so you can create a task file on the fly. I think it's a really cool feature, and it provides tool for analysis. I'll show that in a sec. But I would, from these 4, I would say focus today in Run Process and Rush TI, not only because of performance, but also it's going to be future-proof.
Good call. And I've been putting some of the links in the chat here Obviously, the link that we've got on the slide, we've just kind of put that in the chat, and also a link to an article there from one of our solution architects, Nicole Frigo, in relation to process scheduling and some of these really important topics. So please kind of check that out, and we'll put some more links in a second. And let's jump across to the next stage here, Nicholas, and actually kind of look about it. So we kind of got these, we've talked about the data pipeline. Yeah, and we've given that some consideration, and again, that recommendation to step back and review and analyze and go, well, where in my data pipeline can we do better? And giving that some greater consideration. Whether it's architectural review, whether it's more analysis of how we're getting the data from the data sources. Should we get just the deltas? How do we chunk that up? When we load that into planning analytics, should we be putting it into a staging cube? How do we kind of differentiate between calculation cubes and reporting cubes? And of course, and then also when we're thinking about exporting that data to another data source, maybe you want to put that back into a data lake, or you want to put it into Power BI, or you want to put it into Tableau, or a variety of different tools. Again, how do we, parallelize that and make that highly performant, those extracts? And again, try to keep the end user in mind. And that's where the end user, maybe that's a business analyst or a VP of FP&A, they themselves want to be focusing on analysis and kind of reviewing and uncovering, why revenue is up and why operating expenses are what they are. So we want to get them their numbers as fast as possible. They need to be very performant. They don't want to be sitting there, waiting half an hour for something to run when they themselves are very busy. So, that's something to just again to be mindful of.
And one thing
Nicholas,
I would like to add on
yes.
that, James, is because it's not here, but it's part of it. And this is and we talked about this before. Is you can think of many ways of optimizing TM1, but you should also think of maybe there's some things that for which TI is not fit, right? Maybe you need some externalization of that, and that's not to TM1 shame, right? But there are calculations that are really complex, and a TI process is not the place to run those. That's where solutions like Atmosphere come in, right? So, for example, an IRR calculation is really complex and it takes a long time to do. But if you externalize that to a Python program, for example, it's much faster, and it can come back really quick. So I think that the point in there is TM1 is extremely flexible. It has tons of configuration parameters that can help you do a lot of things, but there are things that can be done better in some other tools. And the key and where we come in is because we know how to distinguish those, and it's really important that you distinguish those, because it will help TM1 as well, right? If you're putting to TM1 a heavy charge that is not maybe capable of doing, you're going to be impacting the end user and TM1 as well. So don't be afraid of, exploring. And if you have questions, feel free to ask. But we've seen this in multiple customers where maybe we just need to outsource that calculation somewhere else and then bring it back in. It's going to be done maybe faster, and it's completely fine, right? So that was the last piece.
Yeah, that's a good point there. And there's a really interesting question here, which we're going to jump into about comparing various approaches to exporting data. And maybe Jason, you've got some thoughts on that in a second. As we go, maybe Nicholas, we go to have a look at some of the tools that you use and we use at CubeWise to analyze the performance. But to that point, IRI is a great example of where we can take that calculation outside of planning analytics and use resources outside of planning analytics, so we can to calculate that and then bring the answer back. So again, you're freeing up planning analytics resources. In doing that, you're optimizing the calculation, and for the end user, it's an overall better experience, and it's architecturally more elegant as well. But Nicholas, would you like to introduce what you're about to show here?
Yeah, so this is a custom tool we made to analyze RushTI logs, right? So as you know, RushTI can output a log file every time it runs, and the reason we did this was basically to see are we actually optimizing the right way. In many cases, many clients say, I just bought an IBM cloud. I got the jumbo tenant, right? And it has 120 cores and it has tons of RAM. And yes, I am paralyzing because I do things per month and account and cost center, et cetera, et cetera. And so it's fast as it can be. So what we do is we put that to the test. So if I show you really quick here, so this is, these are some analysis tools. Let me know if it's big enough or not. Hopefully you can see it. But in this first thing, in this screen here, it's basically a concurrency analysis, right? So in this case, you can see that RushDI was, and again, sorry, I didn't mention this, but what I just did here is I have a sample RushDI log. Any RushDI log would work. I massage it a bit, and I have it shown as like this, where I have the concurrent threads and the max amount of workers, and I just plot this out, right? And what I'm seeing is, yes, you told RushDI to use your 125 cores, but and in some cases you reached like what 99 threads, but it immediately drops, right? And if you see the average running threads during this whole time, it was just 4. So having more resources is not cutting it. For the most part, you went below 4, right? So it's important to not just put money into having more resources. Maybe you should spend some more time analyzing whether or not those extra cores are actually working for you. And in this case, we can clearly see they're not, right? And so then we can go to another type of analysis, and this is again the same build with the same set of data that RushDI uses. And here we have some analysis on processes that had many retries, for example, because there was something wrong with them. And if you hover over, you see that process number 7 had like 5 retries. So we probably need to understand why it happened in that scenario, because that keeps adding more and more time into each of the executions. Here you can see, let me just maybe probably this is better. Yes, I think it's more elegant. So in here, what you can see is that we have all of these processes, right? Some of these are taking longer than others. If you see for process 9, for example, everything is chunked either here or here. So this is odd, right? Why did this happen? So you can hover over and see that when you run it with those parameters, for example, something is not working. And you can see that for every one of these, and you can go to a sparsity analysis, when you can see the outliers. You can see that process 17, for example, has that duration in average for each of the 4 quarters, but this one is the outlier. So the question is, now you have the data, you not only you know that you're not using the full power of your processes, you also know where to look. And this is the point in time where you go to the TI process, you try to analyze it, you time out the prologue, you time out the metadata, the data, and the epilogue, and see where are you spending the most time. Is it building if this is sourced from a view, is building the view taking a long time? Is that view coming from a cube with a rule? What happens if you remove the rule and try again? Then you probably know that if that makes it faster, you probably need to tune up your rules, because this cannot be, right? I mean, everything is super fast. So these are tools that allow you to better focus on where this type of analysis allows you to know where to look. So we have the whole data pipeline, and even in the part in which we are processing data, you know where to go and look.
It also, maybe the first screen you showed, Nico, can also help sort of justify the need for additional resources. I mean, this clearly says that you don't need more resources, but like the 3 of us, we get the question all the time, if I add more RAM or if I add more cores to my machine, is it going to make things faster? I'm like, sure, you can go ahead and you can add more resources, but are you even using all the resources that you have today? So actually, so a company I'm speaking to right now has over 100 something cores on their machine. And my question to them is kind of like twofold. with that many cores on your machine, so you might have that many cores on your machine, but can you prove, or can we help you prove that you're actually leveraging all of those cores? And number two, should you be using all the cores? Because there's a certain point in time where performance might actually degrade if you use too much. So there's that consideration as well. So all of this analysis can help you determine, number one, are you actually getting the most out of the resources that you have? And number two, are you doing it in the right way? And I think those are really two important conversations to have when you're talking about performance in general and adding, or the resource that you have at your disposal.
Yeah, it's a really good point. Again, in summary, as we kind of in summary of some of these things, the big kind of drivers for performance on planning analytics is cores and RAM. And again, how do we maximize the efficiency and the effectiveness of those cores that you have? Or another word for it in the IBM licensing world is PVUs, or processor value units, for those of you who are on-prem. And how do we maximize those? As you said, and as you rightly said, Jason, we do see this from time to time where a customer might have literally hundreds of, or literally thousands of PVUs across a 3-tier environment. But are they actually using them, and can they prove it? And are they using the most efficient way? And how do we enable those customers and help them move forward so the system is performant, cost effective, and overall just a great planning analytics application.
And by
we
the
do
way,
have please
one
go for
quick
it.
thing. So it's not necessarily don't resubscribe to the PVUs. It's more like, let's maximize the value that we're getting out of what we have, and then now that we've made things more efficient in TM1, now we can do even more things in TM1, right? So it's kind of reducing the amount of resources that your current application currently needs to support itself, so that you have more room to do more in the same environment.
Yeah, well said, well said. And there's a really good question that came in here that I'm going to ask. There's two of them, and if those of you who've got some other questions, please feel free, because we're going to move into some Q&A here as we kind of wrap things up. It's been a great week, and here we go. So the question here is, we use Rush TI to orchestrate parallel process and all dependencies between different batches. It works great. We also use run process, but with run process, we still have the challenge of detecting when all threads are done before we start the next batch. Mm-hmm. Yeah, great question, Jason. Like this one's for you. Like, what would you say to that?
Give me a call. we'll put contact information in the chat. So yeah, that is so what we kind of talked about earlier on was our what we call thread tracker. To explain it briefly, how it works is, let's say you have a wrapper process that executes all of a child iterator process. What the master process is responsible of doing is calculating sort of ahead of time the total number of threads that your iterator processes are going to generate. That value gets stored in the thread tracker cube. Then we basically say, as a parameter in the TI process, the total number of threads at any given time that should basically be sent to the TM1 server. So let's say it's 20 threads. And the total number of threads that we need to generate is 300. What the thread tracker mechanism logic does in the TI process, what it does is it basically sends off 20 PI processes, because that's what we said we want our limit to be. And then when one of those threads checks in to the thread tracker cube, so it'll actually write to the thread tracker cube and says, I'm done running. The next, the 21st TI process gets executed. And this process continues until all 300 threads have checked in. But there is a secret sauce that we have built in. It doesn't use Python or anything like that. It's all TM1 cubes, rules, built-in logic like that. But that's our general approach. We basically pre-calculate the number of threads that we need to generate, and then we tell TM1 we only want these to get sent to the server. Because if you have 300 threads that you want to generate and you send them all, if you only have, let's say, 36 on your machine, the rest of them are all going to go into wait status, and that isn't necessarily the best thing either. So the thread tracker mechanism basically sends just the number that we prescribe to the TM1 server. And then the process continues over and over again until all threads have checked in. If you want to learn more, we might have a blog on our website, and I'll send the link out. But for more detailed information, reach out directly.
Yep. It's a great question. There's a follow-up question there, which I'll maybe get you to answer, about what happens if the child process fails. And just before you kind of jump onto that, so again, it's a really good question. We see this time and time again when we get introduced to a new customer and we do a health check, and they are using some run process and they're using the right tools, but there's still some further optimizations that the CubeWise team can deliver here, and some exceptional value there. And we've seen situations, sometimes it sounds crazy where we kind of go in there and they say this process runs for 40 minutes, and then after, with some advanced engineering and some of our advanced techniques, we're able to bring that process, and it happened just the other week when we were working with a new customer, from 40 minutes down to a minute. And again, that's a huge time savings, especially when you think about what that means to the end customer, or the end users, I should say. And also, freeing up the resources, and just, there's such a great improvement there where we use this thread tracker technology to further enhance and enrich some of the steps that you're talking about there. But Jason, what happens if the child process fails? I mean, that's a great follow-up question.
Very good question, and I think so it makes sense, because if we're looking for 300 threads to check in, but only 290 check in, then you would expect that everything just goes in this continuous long loop. We actually build in a smart threshold into the solution. So if a certain period of time passes by and not all threads have checked in, then there's an alert that happens, and basically the whole thing quits. I mean, the threads that have executed properly still, that's all successful and fine. But in the thread tracker cube, you also have, for each thread that gets generated, you have a success or failure status. And if any of the threads have a fail status, then what happens is after a certain amount of time elapses, then the master process basically ends. So you're never going to be in an endless loop situation. That's how we handle it. I also like the comment that Tomas put in the chat. So that's a nice testament to the stability of TM1 itself. So the fact that you can jam up your whatever TM1 top, I guess, what everybody looks at, with a bunch of threads that can all be waiting, and TM1 actually manages that pretty well. We found that sending an appropriate amount to the server yields better performance versus sending everything in an uncontrolled manner, I'll call it.
I guess that kind of talks to kind of some of the topics that Nicholas was mentioning before about chunking up the data. Whether it's when we ingest the data, thinking about how do we kind of put that into chunks or batches, and how we look at deltas, and also kind of realizing the shape of the data can change over time, and being aware that as the data shape changes, we need to be aware of that and kind of react. It's not necessarily a constant environment. It can our data loading processes do need to be dynamic. Nicholas, I think you were going to say something there.
Yeah, so in that sense, I think so. There's the setup, right, that we're showing you and we're sharing with you of how you could probably attack this, using Rush CI, using run process, how to analyze it. But it's not, as James was mentioning, it's not a one-time thing. This setup requires maintenance, especially because it's one of the great why TM1 is so fast in many cases is because how it handles sparsity. But the sparsity of the data may have changed since you created this. So we do have another tool called Optimus Pi, which actually helps you analyze that. So you can over time say you found the right balance, because today the data is located in a specific set of dimensions in this majority. But maybe during the year, or maybe during the years, that data shifts, right, from this dimension to that other dimension, and you added many more products than you were envisioning at the beginning. So the analysis that Optimus Pi provides is, can we, by changing the dimensional order, can we make this process, this view render faster? And that's an analysis you can do not every day, because it would be too much, but maybe quarterly. Just take your production instance, put it in a testing environment, run Optimus Pi, see if you can actually get more speed if you change the dimensional order. Again, this is why TM1 is sort of a living thing, because data moves. If data moves, you have to reevaluating all the decisions you made today. I wouldn't say every month, but give or take.
Yeah. It's a really good call out there. And I guess in the chat there, we've been talking about quite a number of our open source tools here today. And I've just kind of put a link in the chat for those who are interested. And Optimus, some of the TM1 Pi tools that we're talking about that Nicholas just referred to, you can get some more information there from the TM1 Pi link that I just put in the chat. So a lot of this stuff, is available on our CubeWise Code website, which is purpose built for TM1 developers and administrators who want to kind of take planning analytics to the next level, further enrich their application with some of these tools. All right, gentlemen, I think we are almost about to wrap up CubeWise Innovation Week. So I don't know, Jason, in closing, anything you want to kind of say here? It's been a great week, but anything in closing you'd like to say?
I just want to say that over my years and experience with TM1, from my perspective, because we've sort of evaluated quite a bit of the other solutions out there, it's still my favorite, and I think we all kind of share that perspective. But just more broadly, I think one of the things that CubeWise brings to the table as far as value is, as James mentioned at the top, because of our global sort of footprint and the way that we share data, information internally, we provide that value back to the customer in sessions like this, but also in during consulting engagements. And it's not necessarily because other people don't know what they're doing. It's just because they don't know what they don't know. And we sort of have that advantage. If someone's at one or two companies and they do pretty much things are, they understand their company very well. But maybe if they're going into they want to build a new use case in TM1, or they want to do something a little bit better, we can bring other perspectives, right? And that's why I like these webinars that we do every so often.
Nicely said. Yeah, I guess that's that depth and breadth, and that I guess that laser focus on the planning analytics, and that we're really kind of that pursuit of that. Being an advanced practitioners of planning analytics with our consultants and our engineers and the like. What about Nicholas? What about you? What was in summary? How would you kind of wrap up the week from your perspective? So I know you've been on 3 of the sessions, doing some heavy lifting there. So a big shout out to you there. But anything you want to say in closing?
No, I think it was a great week. Tons of new things to share. Some on old topics like parallel loading, and some new features as Atmosphere, and some new topics as DevOps. I think it was a great thing. I think this is the place where you're going to get those new topics, and we are amongst a crowd of people that like to explore these new things, right? We know that TM1 can do much more than building a P&L cube, and we love to take TM1 and to push it and to push it and to push it and to ask more of it. And that's why we are the nerds of TM1, right? And we like it. So yeah, that's it.
Yeah, well said, mate. Well said. I agree. So, I guess in closing, I just want to thank everybody from the CubeWise team who's participated and helped us bring this CubeWise Innovation Week and the webinar series together. So a big shout out to you all, and a big shout out to everyone who's attended. We can't do this without you. And the feedback and the support on this has been great. So we do want to thank everyone in the planning analytics community for helping us bring this together. I've really enjoyed doing this. This has been a great exercise, again, of helping us share our knowledge with the planning analytics community, because again, it's in our DNA to help everyone kind of advance planning analytics. And as Nicholas said, there are so many use cases for planning analytics across the enterprise, and we would love to work with you all and kind of help support that as we all kind of advance planning analytics. So, as I said, these sessions have all been recorded. They'll shortly be available on demand, and things of that nature. So, I guess in summary, that is a close for CubeWise Innovation Week. I hope everyone's had a really informative and enjoyed the sessions, and have a great rest of your day. And keep doing good, TM1, and thank you very much.
Good weekend. Bye bye.